Welcome again to another episode of Math Tutorial for Grade 10 Mathematics. I'm here again, your Sir Darwin, to give you a discussion on third quarter Mathematics 10. Specifically, this is the Distinguishable Permutation. For our learning objectives for today's lesson, you should be able to first illustrate distinguishable permutation. Second, we need to solve problems involving distinguishable permutation. But before we proceed with our next lesson, let's have first a recap of our previous lesson on the permutation of n objects taken r at a time. Remember that we use the formula n permutation r, which is equal to the n factorial divided by the quantity of n minus r factorial for the permutation of n taken r at a time. So, I have here a different set of problems to check your understanding from our previous lesson. For our recap, let's answer the following questions. So, find the permutation given its n and then the r. So, for the first one, n is equal to 7 and r is equal to 4. Number 2, n is equal to 6 and r is equal to 5. For number 3, n is equal to 12 and then r is equal to 2. If you think your answer is right, just comment your answer in the comment section and I will be checking if your answer is correct. Okay, learners, let's check if your answers are correct. So, for the first question, 7 permutation 4, that should be equal to 840. For number 2, your answer must be 720 from 6 permutation 5. And for number 3, your answer from 12 permutation 2 must be 120 possible arrangements. Okay, so after our recap, let's move on now to our lesson for today, which is the distinguishable permutation. Let's start the lesson by defining distinguishable permutation. So it refers to the permutation of set of objects where some of them are alike. So we have number of permutation of n, which is the number of the things involved where p are alike, q are alike, and so on. So for distinguishable permutation, it talks about the arrangement of things where some of them are alike. So for the formula of distinguishable permutation, we have p is equal to n factorial divided by p factorial multiplied by r factorial times q factorial and so on. So let's go back with the formula. So for the numerator part, we have n factorial. It talks about the totality of the objects, things. It can be letters, it can be numbers on the given. But for the denominator part, we have p factorial, r factorial, and then q factorial. Those are the things that are alike. So we need to count how many things are alike and we are going to put them on our denominator. So to better understand the formula, let's have some examples. Let's have our example 1. So for the question, how many distinct permutations can be made from the letters of the word success? Okay, so first thing to do is to count all the letters of the word success. Okay, learners, so let's count the total number of the letters of the word success. So from the given, we have all in all 7 letters from the word success. So that should be the value of our n. So n is equal to 7. So for the parts, let's count how many letter S, how many letter C, how many letter U, and then how many letter E. So for S, we have 3 letter S. For our C, we have 2 letter C's. And then for U and E, it has 1 for both. So we have 1 letter U and then 1 letter E. From that given, we can now solve for its distinguishable permutation. So we have P is equal to, from the formula, n factorial divided by P factorial times R factorial times Q factorial. So we are going to put those given from our formula. So n is equal to 7, so that will be 7 factorial divided by, since we have 4 letters, from the formula we can add another letter. So we have, for the denominator, we have 3 factorial times 2 factorial times 1 factorial and times another 1 factorial. Remember that from our numerator, we have n is equal to 7. So 7. And for our denominator, you must total that and you must get a total also of 7. So to make it a solution. So we have 7 factorial divided by 3 factorial times 2 factorial times 1 factorial and then another 1 factorial. So for the result, we have 7 factorial as 5040, and for our 3 factorial times 2 factorial times 1 factorial times 1 factorial, we have 12. So if we divide 5040 and 12, we can get the answer as 420. So we have a possible arrangement for that word success, which is 420 arrangements. That is our first example. Let's move with our second example. So from the given a while ago, which involves letters, let's now move with examples using numbers. So the question for example 2, arranging the digits in the number 0966069066. So the first thing that you need to do is to count all in all the numbers. So regardless, even if it is repeated, you should be counting that. So n is equal to, all in all, the numbers are 11. And after that, let's count how many 0, how many 9, how many 6 are there. So let's start with 6. So we have 6 sixes. And second, we have 0. So for 0, we have 3 zeros. And then for our 9, we have 2 9. Okay, so let's move with the formula using that given. Okay, so let's move with the solving part. So P is equal to, again, that is n factorial divided by P factorial times Q factorial times R factorial and so on. So we have the numerator as 11 factorial. For our denominator, that is over 6 factorial times 3 factorial times 2 factorial. Remember that the total of our denominator must be jive with our numerator. So 6 plus 3 plus 2, that is the same as 11. Okay, so let's simplify. 11 factorial is equal to 39,916,800, while 6 factorial times 3 factorial times 2 factorial is equal to 8,640. And by simplifying that again, we can get the answer as 4,620 arrangements. So the possible arrangement of the set of numbers 0966 06 90666 is equal to 4,620 arrangements. So that is our second example. Okay, learners, I hope you understand all the examples given for the examples on distinguishable permutation. Now, I prepare 3 seat works for you to check if you understand the discussion. So this is the same as the previous examples, wherein you need to illustrate and solve problems involving distinguishable permutation. So for the first problem, letter A, how many distinct permutation can be made from the letters of the word lollipop? Letter B, arranging the digits in the number 6888222233. That is letter B. If you like to check if your answer is correct, I'll be posting it to our wall to check if your answer is correct. These are the answers. So we have, for letter A, we have 1,680. Very good if you get the correct answer. Letter B, the answer is 5,040. Excellent. So that are the answers from the questions from the previous slide. Very good if you got all correct answers. Congratulations if you answer all questions correctly. And again, I will be leaving some questions related to distinguishable permutation for your practice exercise learners or homework. You can answer the following. How many distinct permutation can be made from the letters of the word statistics? So that is letter A. Another one, arranging the digits in the number 1110111. Take note, learners, before we end. In solving distinguishable permutation, you need to count first all total number of objects, things, letters, or numbers involved, divided by its number of objects alike to solve the distinguishable permutation. So for our formula again, we have permutation or distinguishable permutation is equal to n factorial, that is n, which is the total number of objects, divided by the objects that are alike, the number of objects that are alike. So we have p factorial times q factorial times r factorial and so on.